This video is going to go into the details of what different types of validity exist and how to measure them. The validity question. You can always be asking yourself these questions. Is this research measuring the right thing? And how many ways could this be wrong? In other words, how accurate is this? This is the validity question. So how many different types of accuracy are there? How many different ways can a thing be true? Construct validity is about whether you're actually measuring the thing you're claiming to measure. For example, you may have observed that a lot of smart people you know are tall, and therefore you believe height is a good measure of intelligence. This is obviously wrong. A more subtle example might be using body weight to measure how physically healthy someone is. This doesn't take into account how tall they are, how dense their bones are, how muscly they are, which, for example, body mass index provides a better measure for. But then even BMI ignores sleep, diet, emotional well-being as other metrics of health. Another example would be using a car's speedometer to measure driving skill, or using the quantity of time someone works to measure their productivity. The point is that normally there is the real-world variable you are trying to measure, for example, health or driving ability or productivity, and this is represented by the bullseye in the target. And then there are all the different methods people can use to try to measure that target variable. Again, we can think of the arrows as different methodologies people can use. Some of those methods will be closer to the bullseye and therefore have greater construct validity, and some methods will be further away from the target and therefore have weaker construct validity. What is ecological validity? Ecological validity is sometimes called external validity, and it is about how close the measure is to the real life variable. The clearest example would be using the behavior of animals in a zoo to represent the behavior of animals in the wild. If we think those two things are the same, then we're going to have a nasty surprise when we go and hang out with animals in the wild. In decision-making experiments, a little bit of a change, this is the difference between giving people fake money to play with versus real money. And driverless cars is another example of this. It turns out that there is a huge difference between driving simulators and driving in real life. In all of these, the closer a measure is to the real life conditions, the greater ecological validity it has. Predictive validity, meanwhile, is about how effective a measure is at predicting a real-world measure. For example, spatial reasoning is a strong predictor of success in science, technology, engineering, and maths careers. VO2 max is a strong predictor of cardiovascular fitness. Your credit score is a great predictor of whether your mortgage will be approved. Whether predictive validity is important for an experiment varies massively. For research that is applied and is meant to have a direct applied impact on the real world, for example, clinical settings or in medicine, then predictive validity is incredibly important. Imagine a new weather forecasting tool that can't predict today's weather. No one would use the tool because the value comes from its ability to predict. In the same way, if research is meant to predict an individual's chance of developing a disease, or to be able to predict whether someone will be diagnosed with a condition, then predictive validity is very important. Not all research needs to have strong predictive validity. This is up to you to identify whether the predictive validity of the measure is important for the research question at hand. Face validity is a slightly simpler issue. Face validity asks, would this convince you before seeing the data? It asks whether the method makes sense to a reasonable observer. It's about first impressions, not statistical proof. If it doesn't resemble the real skill, face validity is low, but when it does resemble the real skill, the face validity is strong. Whenever you are reading a research paper, you can be thinking about the validity checklist. Does the paper you're reading have construct validity? Does it have predictive validity? Does it have ecological validity? And you guessed it, does it have face validity? Every research paper that exists can be ranked on these 4 dimensions systematically. If you want more ways to critique scientific research, check out my video on reliability next. Alright, see you soon.